Okay, today we are going to look at modeling with exponentials. Okay, so basically what this means, this is stuff that we do a lot, or they do, people do, is they figure out models that go with data. So this is specifically exponential. So if you think about, so far in this class, we have really just talked about lines. Linear functions, okay? A linear function is in the form y equals mx plus b. Basically, when I look at a linear function, it's a straight line, like something like that, okay? So people are always trying to make predictions. So they figure out from past data, and they try to come up with something that fits the past data so they can make predictions for the next few years or for 100 years from now. Okay. An example is they reintroduced the wolf into Yellowstone National Park. Okay. They were not expecting it to grow as fast as it did. The population grew really fast. So now they're looking at the data from when they introduced it, how many they put in, and how many they have now, and they make predictions on how many they will have in the future based on that model. Okay, so if they're looking, I don't know the data on that, okay, but the data is that they're predicting how many they're going to have and what are we going to have to do if it keeps growing at the rate it's growing. Maybe what are its natural predators so they can introduce more of those so there gets to be a balance in there. Okay, yeah. So, but what I'm saying is they introduced the wolf back in, they weren't expecting the growth that it has. And so then they look at the data, okay, over the first 5 years, the population has grown this much. It's growing exponentially. If we let it go, it might just continue on up in the exponential. Maybe not either. But
well, you have to also compare the population of the elk, because
okay.
if the population grows
Matthew,
here, then
I know.
go down, and then this.
We're just talking about this right now. Other factors come into play. Okay, I will agree with that. But right now, that's giving you an example of what they look at. Okay. So we have also talked about exponential growth, and an exponential growth is y equals abx, where b is greater than 1, okay? If I were to graph it, it kind of starts out slowly, and then it goes really fast up. So it starts out slowly. In fact, an exponential growth in the first few years is less than a linear growth. Okay, so if I were to put these two on the same graph, the linear line would go kind of like that down here. Okay, it would be lower for the first few years. Okay, so it's a slow growth pattern and then it just accelerates. That's one we've looked at. We've also looked at exponential decay. Which is when we have y equals a b x to the x, and b is between 0 and 1. It's fractional. Okay. If you look at the picture of that graph, it drops really fast and then kind of levels out. That's a little bit exaggerated, but it drops fast and then it starts to level out, so it slows down. So growth starts slowly and then speeds up. Decay actually goes fast and then slows down. Okay.
What if it slows down and goes down?
If it slows down and goes all the way down, then usually we don't use exponential decay. Okay.
No, but what if it goes like this? Like the exponential growth trend inverted, like it goes down fast. No. It slowly goes down and then it goes down really fast.
Then you call them dead. So it's like this.
Rather.
Oh, that is not exponential. Okay.
Yeah.
That's gonna be a quadratic.
Ah.
So we would use a different thing to do it. Exponential growth is this shape. Exponential decay is this, okay? And so that's basically your exponential. If it's going down like this, it's usually it could be a negative shaped exponential, which has a negative a. That means it has a negative starting number. That would be kind of weird, okay? Usually we represent that as more quadratic, okay? So those are the different ways we can look at it. So what we do is we take data and we check to see which of those kinds of things, or that's what people do, is they look at data, they check to see what kind of pattern the data is fitting, and then they try to make lines or equations up to make predictions. Okay. So we're going to take this experiment that is question Y on page 420. So if you want to open your book to page 420, there was an experiment done. Okay, he dropped a ball. Okay, guys, we're looking on page 420 right now. Okay. So this person dropped a ball from a height of 0.912 meters. That's probably close to a yard. Okay, because a meter is a little bit more than a yard. If you use 0.912 meters, it's probably about from 3 feet high. Okay, he recorded these rebounds. So if I drop a ball, it's going to rebound higher, and that will naturally get smaller rebounds. Think of a bouncing basketball, okay? If it goes out without you touching it, it rebounds higher. The next time it's not as high, then it's not as high, and pretty soon it's on the ground, okay? So this is what he recorded. So on the first 0, he started at 0.912. Then he had these different ones, and you might want to write these down on your paper because we're going to show you some stuff on this. Goes up to 6. Okay. I'm going to pull this up so I can see it. Okay, now it asks us to write an exponential equation for this. Now, if you look at that, what kind of decay, oh gosh, that's great. What kind of exponential equation would it be? Yes.
Probably decay.
Probably decay, okay, yeah.
What made you say that?
Yeah, what was your theory? I don't know, it was just a wild guess.
A wild guess. So, if you look at it, we are definitely going down. And as we go down, it's increasing maybe a little bit, okay? So one of the ways that we did it back in the day, before we had computer programs, was we took what is the change? What did I multiply by to get from here to here? Okay, how would I determine what I multiply? Because remember, we're looking for that common multiple that we go use all the way down. What did it multiply by each time to get down there? How do I find what we multiplied by to get from 0.912 to 0.759? Division. So we take this, this number, 0.759, and we divide it by 0.912, because that means whatever I get here is what I multiplied 0.912 by to get 0.759. Somebody have their calculator out so they can do that.
That'll be 0.8.
0.8?
3.
0.822.
8322.
Yeah,
Okay.
sure.
Okay. So the next one is going to be, of course, we want to get this answer, so it's 0.603 to 0.759. The next one's going to be 0.496 divided by 0.603. This is going to be 0.411 divided by 0.496. So each time I'm just taking the next one, dividing it by the previous one, because it's a decline, okay? So I'm going to take the next time, it's 0.328 divided by 0.411, and the last one is 0.271 divided by 0.328. So we're looking for what is the number I multiply. We're looking to see if it's a constant number, okay? So let's have different people do it. Grayson, you do the second one. Who has it? Med, you do the third one. Do you guys have calculators?
I know.
Okay. You do the fourth one. Brielle, do the fifth one. Let's see. 1, 2, 3, 4, 5. I'm done. Okay. So this is the first one, right here. Second one, third one, fourth one, and fifth one.
So I'm doing the fourth one.
I think that's what I said.
Okay.
I thought I was doing the first one.
I thought I was doing the third. His fourth, my third. You changed the numbers.
Oh, did I? Oh, I'm sorry.
Because now
Okay,
the
I
first
called
is the
this one
second.
2. Okay, 2, 3, 4.
Yeah.
Okay, so Ava, do number 6.
You're simple.
Is that for number 3? Is that a 4 or is that a 9?
What?
No.
Look at the
Look
at the numbers up there.
Not anymore. It's handshakes now.
Yeah. Okay.
Okay, guys, let's not screw around. Okay, what'd you get, Grayson?
I got 0.7944.
0.7944. Okay. Who was 3, Med? What'd you get?
1 point.
0.496 divided by 0.603. Not going to be 1 point.
I'll do meds.
Yeah, Max, you can do it better than him.
You guys could do it all.
You're doing it backwards. It's
Did it backwards?
496
No.
divided by 0.603.
496 divided by what?
0.603. He's doing it too.
0.8225.
0.822553897.
Med did it better.
No, it didn't go that.
Okay, Mr. 4.
0.8286.
8286.
Oh,
Yeah.
it rounds up.
Okay, Brielle
0.7980.
and Ava.
0.8262.
Okay. Now, if you looked at these, does it look like we're being pretty consistent with the number that we're going down, multiplying by? In a way it is, okay? So what we normally do with this is the old-fashioned way, is we found all those, we are gonna average that, okay? So we're gonna add these all up, divide it by how many there are, and we're gonna get the average number that we multiplied by, okay? So people do that, let's have several people do it to see if we get the same answer. Add them all up, there are 6 of them, divide by 6.
Okay, that's 8. Not 6.
I mean, it's 7, you mean?
I have to clear everything.
The fourth one.
This one is
that kind of
point-
looks like a 6.
It's an 8. There we go. That was a lousy 8, I'll agree with you.
Why is that on 4?
Yeah, there should be 6.
There are 6 numbers there,
Yes.
I do know
No,
that.
yeah, I know. I was just saying.
Oh,
I wrote it down as 6, but then I was like,
yeah.
that's not right.
1, 2, 3, 4, 5, 6. Okay.
So
I have it.
What did you get?
4.2134.
This is adding them, right?
Yeah.
4.2.
No, wait. Times.
No, not times.
No, and I know I did.
Okay, wait. Tell me what you're giving me. Are you giving me the sum of these?
No, I gave you the one that I divided by.
Okay. Anybody else get a number? What did they get when they summed them? If you've already divided by 6, just give me that number. Braille, did you already divide by 6?
Yeah.
What'd you get?
4.2134.
That's the one that I gave you.
Divide that by
Something's
6.
I
wrong.
did.
I got 4.9.
Divide by another 6.
Okay, wait.
I got 0.
Stop. Okay. Let's all add them up first.
Okay.
0.8322 plus 0.7944. Just add them up and get me that number. What'd you get?
From just that, I
Just
got.
adding.
Okay, 4.9019.
Okay, now I want somebody else to add them all up and see if that's what they got.
I got 4.9019.
Okay, check. Okay,
I got that too.
you got that too? Okay.
What am I on? 8225. Point.
And then we divide that by
That's
6.
what I got too.
You got that too? Okay,
6.
since we're getting that many people. Now, take that number
And divide it by 6.
and divide it by 6.
Good.
Okay,
Already
so so we totaled them, the total, and now we're going to divide by 6. That's finding the average, okay? So what is it when I divide that by 6?
0.816983.
I rounded up because those numbers were, I wanted to go to the 4th digit, so it would be 0.7.
You missed it.
Okay.
Point 83333.
I don't care about the rest. So at this point, I wanted to round because I used 4 digits here. So we really rounded to the 4th digit behind. That's usually what you do because you don't want to go more accurate than that. If I'm only using 4 digits in the actual calculations, I shouldn't go beyond that when I get my final calculations. Okay. So now, this is the average amount that we would do. So that's what is our exponential growth rate, okay? So if we were to write this as y equals a times bx, this is the decay rate, which we just found the average decay rate. We looked at each individual decay rate. We found the average, which is 0.8170. So this is 0.8170. We need to know what A is. What is A?
A would be the starting number. Wouldn't
A is my starting number. My starting number is right there, which is 0.912. So now I have A and B, so I have my equation. So y is equal to 0.912 times, and since these are all lots of decimals, 0.8170 to the x power, okay? I put it in parentheses so it's a little bit easier to see. You don't have as many decimals and multiplication signs in there, so it's easier to see what's going on there, okay? So now we just found the equation. It asks now, what would the 8th bounce be? How would I find the 8th bounce now? Yes.
Would we now use this equation and put the 8 in for x?
Yes, you would put 8 in for x and use that equation. So right now we would project.
No, this definitely goes to Grayson.
Okay,
No.
we don't need to do that right now. To the 8th power. People, use your calculator and see what we get, because I want to make sure everybody's getting the right thing. Everybody do it right now with your calculator.
Oh.
Figure out what you get. I want to make sure everybody gets the right answer because they put it in their calculator correctly.
I hope I did.
It should be less than 0.271, I'll tell you that much. Because it's a decay function, and 0.271 is the last one, so it should be less than that.
Okay, I got it.
Everybody got it? I'm gonna wait for
It's
everybody.
so fast.
That's fine, don't worry.
I'm worrying because I'm panicking. I typed it already.
Okay. Mad, what'd you get?
0.181.
0.181.
181.
What did you get, Grayson?
0.181.
What did
Same
you
thing.
get, Brielle?
0.181.
Okay.
Who would've thought?
Anybody else get something different?
I didn't do it. I was writing down
Oh,
notes.
it's actually
And what did I say?
I'm sorry. I
Everybody
was
in the
finishing my
class
notes.
was supposed to do
Took away
this.
his participation.
Okay, so this is basically based on the data. Okay, so based on this data that he collected in his experiment, he was able to come up with a formula that modeled the bouncing ball. Now, if he did it again, would the bounce be about the same? Would you think that that same ball would bounce and decline the same rate?
Possibly.
Possibly. Yeah, especially if you start from the same measurement, okay? You don't want to start higher because it's going to change things a little bit. But if you start at the same one, it should, if the ball is the same, conditions are the same, it should bounce about that amount.
Wait,
Okay.
so if this is, you guys are saying this is decay, right?
Yes,
So if that means it will never technically,
correct. It never technically hits the ground.
or stays
Okay.
on the ground.
Yes, yes.
Yeah.
Okay, but
'Cause
we
atoms
know,
don't touch.
we do know that it does. So remember, it gets so small theoretically that we can say it's zero. Okay, even though the numbers go infinite, we can go down and say it's zero because they're so small. Which you're correct. I use the example that atoms don't touch. Okay, so that's why you can know that you really technically don't get down to
I
zero.
don't see atoms.
Okay,
In my mind.
there aren't any. Okay, so what we're gonna do is I'm gonna have you go up and you're going, oh, they gave the solution to that one. No, we're gonna do one over here. Okay, so I want you to go up to the board. Everybody, there's a pen, so get in groups of 2 or 3.
We get to pick our groups.
You can pick your groups for right now.
Stack all right, all left side.
Me and
Yeah, us
Grayson work
three.
well together. But then,
Aww.
okay, yeah, that works.
Can you choose the groups?
Do you want me to really just
Don't worry,
choose
I'll hug
some out of hats or something?
Sure, yes,
actually
yes.
Matt,
No, we're
don't ruin
fine.
it for all of us.
Guess
please.
what? I will. If I'm going down,
Matt,
Yeah,
you're
with
so
me.
selfish. Come on, you're like driving a car. You shouldn't be selfish. Like anyone that says
Now, who's
that
being
really-
selfish here?
Yeah.
Oh, wow,
You.
man.
No,
I just want to pick.
trying to
We're
crash
already
into
in a
a
table.
Matt, are you trying to
Yeah,
crash
we're
into a
back
church?
to a whiteboard.
I'm trying to crash into a church.
Sounds like you're
trying to get the best partner.
Okay, everybody turn their book right now.
do this on my own.
Everybody open your book to 422. You can start looking at the problem. We are going to do number 5. It gives you a table.
No. Oh wait.
What's that
Okay.
paper for?
What do you think it's for?
A drawing?
Yes.
No.
I'm gonna put M on it.
Well, there's 4.
Oh.
Can I be on
No,
my?
That's smart.
There's 4 M's.
I know.
There are 4 M's.
There has to be like a special M. M with a smile, M with a smiley face.
Two middle names.
I have to go.
I'm the better M.
No, I'm not.
I got a
Just
D in
say
that
my middle
space,
name.
I'm the best
I
M.
got D in that space.
Yeah,
Wait,
guys,
guys,
my
middle name.
name.
Start my
Good.
Yeah, no, they.
And the last one are all different. I can just use your first letter
How we're gonna word it.
on those.
So is this the computer's memory one?
Yes. You're doing number 5, the computer's memory. If you look over to the side, there's actually a chart. Okay. part of it you have to, there's a little bit of difference you have to look at. I'm gonna have to
Then fate will
have you
us work
explain a little bit on that one,
Also, that is
okay?
terrible.
No, I know.
Okay.
Imagine.
Pick your partner.
Oh.
What are we working on?
Well, I guess it was in 77, so anything.
I need
Mine's like
that's what oh, I
to make
Just explodes.
Even 500.
You can't pick
Why did I say
yourself,
that?
I'll take you out.
What about 23?
Oh, that was like
Or
around
there's 4.
like 2010.
Pick one.
500 and. What is it? No, 77.
That's who
I
you're
don't know.
with.
It's 2000.
Matthew,
I'm
pick your
on
partner.
How do you know?
Draw yourself.
Because what's 1977 plus
Who's W?
1997?
Who's that?
Oh.
That's B, that's
Yeah.
Brielle.
Oh.
Okay, and I'm not having you.
What?
If you draw yourself, it doesn't count.
I draw myself. Oh, oops. Oh, sorry. I got a little mixed up.
Let's see.
That means it's.
I have one last.
I got you.
So I have Max, you're taken care of. Matthew's taken care of. I have a blank one in here. Why did I write a blank one?
It's a wild card. You get to choose whoever.
One person
It's
It's me, isn't it?
No, there should
I have to
be.
go too.
Wait, you can just get a pick who.
Yeah, I
I
can pick
got, no,
whoever.
I got you, Grayson.
No, Ava.
Wait, Matt's on his own?
So,
I wanted a partner.
Matt, choose a number between 1 and 3.
1 is over there.
27.
Should
I'm
look
gonna have
that
to
way.
do
1's over there.
1.
You're doing 1? Okay, you're going with
I called it.
Ava and her partner.
Ed.
I called the 1. Let's go.
Okay, so group 1 is Ava and her people. Go up to that board.
Ava and her people.
Matthew, who are you with?
I'm with Brielle.
Brielle, you guys go to that one. And then whoever's with, it must be Mason and Max. Okay.
Team name.
Eminem.
Okay, so you are using number 5. Okay, problem 5.
Okay.
I want to give you a hint though.
Okay, so
Wait. Are you guys listening?
0.
I am.
Hang on.
Oh, yeah.
Okay.
how many?
This one doesn't,
Here, first.
Okay, guys.
$2. Sorry.
this one, if you notice, does not go up by ones. Okay. Actually, maybe we'll do the theater gross ones. Nah, don't like that one either.
I like number 5.
Well, the problem is it doesn't go up by 1.
I like 11.
So, oh, that's a good one. Let's do 11.
Yes.
Let's go, Mason. Carrying the team.
Let's do 11. I just want you to find the equation. Want you to find the equation for number 11.
So,
So just find it, okay.
11B. 11B.
use an exponential regression to drive it.
Okay. Wait, what's the top say?
If they don't go up by 1, they can't use my method.
Yeah.
No, this is
It'd be
my
very
calculator.
complicated.
And then what?
Yeah, that would be pretty wild.
I think I know
Okay,
it,
so then
but I'm
we have
not.
one up there.
The number of pennies.
Yeah.
Are you gonna show them how to
Just
use
like-
a calculator?
It's kind of like.
The calculator doesn't, well, the calculators
like,
may do it. I don't think mine does.
the
You
previous
have to have a
numbers,
TI.
got the
83 or
addition makes
84.
sense because 2 and 2
Yeah, I know it doesn't
make
do it.
3.
Do you have my T83 plus?
No, I bought one.
But like 3 and 5 is 8.
Yeah, because it's
8
pink.
and 5 is 13.
Oh.
8 and 13
I'll have to look in my.
You know what?
is
I may have taken yours when I taught at Clark.
That's what I thought.
So I can give you my pink one.
I want my actual 83 plus.
I don't think I have it anymore.
You
I
got rid of
think,
it?
no, I think it got stolen at Clark. That's why I bought a new one.
Actually 13.
Okay, that's
She said to just.
25.
Yeah, you don't have to plot them. You're finding the equation like we did in the example I did here.
So,
What we did
So
before
it's
is we just took.
y equals.
Okay, so